In this video, we will see how to quickly create the structure of a building within 3D Experience using building structure application available in Building and Civil roles. When launching building structure application, a building product is automatically created. I will first create a grid that will be used to create my structural members using the position sketch on story. Each segment of this sketch, as each intersection node, will be usable to create structural members. I constrain the sketch to have the correct spacing. I will also create an arc to see how we can handle curved beams. Once my sketch has been created, I can create my building grid. The grid needs a profile as input, which is the sketch I just created before, and a number of stories. The default height of the story is set in your preferences, but you can of course change it afterward. There are some advanced options to scale or twist your grid from the bottom to the top, but we will stay simple for this tutorial. My 3D grid has now been created, such as my rock breakdown structure with a ground story, story 1, story 2. First thing I want to do is set up grid labels. I can either launch the grid label command using its icon in Style tab, either pick a grid segment and use the contextual menu to create the label. I can define the first label name, rotate the text, define a jog for the text, or change the length of the extension line. I can also hide the left or right label or keep both of them. Once the setup is done, I click on Create and pick a second grid segment. The label is automatically incremented. Then I will change the vertical labels to a number, and those are also automatically incremented while picking new grid segments. Now that my grid is defined and my labels are all set up, I can go to Catalog Columns command to instantiate my columns. I have two ways to define the profile of the member, either from a standard catalog, either a custom profile, which will be a sketch for example. I will use the catalog mode, and here is the list of the standard members delivered with the application. Each standard provides access to specific shapes, and those shapes exist in different sizes. Once I pick the size I want to use, I can either position my column on a grid or on a wireframe feature. By selecting the grid, all grid segments and points are displayed. If I pick a grid segment, a column is added. I can change the alignment with reference to the grid segment using the arrange dots or the align icons in the panel. Column can also be rotated using main orientations or by inputting a specific value. Column can also be trimmed or offsetted in U or V directions. The great advantage of using the grid is the usage of accelerators. I can, for example, choose the above and below mode, all in story, all in building, all interior, and so on. I will define the sides of my building with all on-site mode to create my columns. At any time, I can multi-edit several columns using the Control key and the contextual menu. This will allow me to perform modifications on several members at once, such as the rotation of 3 columns in this case. If I want to have a single column going through the 3 stories, I can pick grid points, and if an accelerator is defined, such as all interior in this case, it will replicate the same behavior for other points. Now, let's define the beams using catalog beam command. Options are the same, and I will use the all-in building accelerator to create all the beams in one shot. Now, let's say that I want to have curved beams. I can delete the 3 straight beams in front of the building, launch beam command, and activate the show curved grid segment mode. I can then select those to create the curved beams. Then, I can create secondary beams using the catalog beam pattern command. I will select the start and end grid segments to be used to instantiate those beams. I can either define a count of beam or a spacing between those. Then, options are similar to what we have seen before. I can use accelerators, such as all-in story. To add the beams also on the second floor, I define a start and end segment on the second floor also, and because of the accelerator, beams are also created on that story. I can change the size of the beam. Finally, I align the top of the secondary beams with the grid segment. Then I can define a truss at the top by using the bar joist pattern command. There are different series and designation available. I will also use the all-in story accelerator, and as for the beam pattern, I will pick the start and end segments of one truss. The accelerator will make all the others automatically picked. If you want information about quantities, use the structure estimator that will generate a report that can be exported. You can see the total volume of structural members in the Building tab, information about trusses in the Joist tab, and about beam and columns in Catalog Elements. There, you see the size, length, unit weight, count, and total weight of the different members. All the beauty of CATIA is to be able to change the grid and having everything updated. I can edit the grid sketch at any time, change the distances, and when I exit the sketch, all my members have been automatically recomputed following the grid. I can also add a slab if I want. To do so, I activate the story where I want my slab to be designed. Then, with the Position Sketch on Story command, my sketch will be automatically positioned on the active story. I can constrain my slab with the grid sketch so that every changes occurring on the grid sketch will automatically be propagated to my slab. Then, in Building tab, I can define a slab, pick the sketch I just defined as input, and define the direction for the slab. If I'm not happy with the result, I can pick the slab and re-edit it using the contextual menu at any time. In this contextual menu, there is also a copy to story command that will allow me to copy the slab to the second floor, for example. Now, my conceptual design is done. I can export it in SDNF, for example, or use the generate simulation command to automatically mesh it for similar applications. Right now, all my members are features stored in a single structure container. I can use the generate building product structure command to automatically generate a BIM IFC compliant structure. Now, one part has been created for each of my members and have been stored in its corresponding story. I can save it and export it in IFC to share it. As you can now see, it can be opened with other softwares. IFC structure is available, such as the member size and quantities.